Here is our practice quiz for radicals, simplifying and dividing radicals. We always want to consider our OPVER, odd-powered variables from even roots. We don't have any variables here, so we don't have to worry about this time. But let's begin by breaking down the square root of 60 and the square root of 30. Okay, so we have broken down the square root of 60 and the square root of 30 into its prime factorization. Now we're going to look for pairs and pull them out. Once we pull out our pairs and we put a 2 here, we have 2 times the square root of 3 times 5, no more pairs. Over here we broke it down, prime factorization, 3 times 5 times 2, no pairs, so we have to leave it. That's the square root of 30. This is 2 square roots of 15. The radicands are different, so this is our final answer. Second problem. Let's start by breaking down the radicals. So we have our radicals broken down into prime factorization. Now we're going to look for pairs. We pull out our pairs, which get multiplied by the term that's already outside. So now we have 8 square roots of 3 minus 18 square roots of 5 plus 25 square roots of 3. Do we have any like terms? The radicand will tell us which ones are like terms. I have the square root of 3 and the square root of 3, so I can bring those two together. Final answer, 33 square roots of 3 minus 18 square roots of 5. Okay, our next problem is a fraction, which when we separate this, you'll see a radical in the denominator, but let's simplify it first. Okay, now that we have it simplified, 10 over 24 is 5 over 12. I see variables in here, so let's go back to our saying OPVER, odd-powered variables with even roots. Well, I know I have variables, and I know it's a square root, so I'm going to have to consider this when I'm done. First step I'm taking, go ahead and separate the radicals, and then I'm going to break down the square root of 12. So we've factored down to prime factorization, the square root of 12. We pull out our pairs, and so now we have 2 times the square root of 3. So on our next line, what we're going to do is we're going to rationalize the denominator and get the square root of 3 out of the denominator. So once we rationalize and multiply the top and the bottom by the square root of 3, we have a pair under here. So the 3 is going to come out. The 3's are going to come out. So we'll take it to the next line and we'll simplify. So now we've simplified everything down. We multiplied the 5 times 3 and got 15. A to the 6th power is A times A times A times A times A times A, and B to the 5th power, B, 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 B. So let's pull out our pairs and simplify. So let's take a look at what we have. We have 3 pairs of A's, so that comes out as A to the 3rd power. 2 sets of B's, so that'll come out as B to the 2nd power, times the square root. 15 couldn't come out, no more pairs. B has to stay in, all over 6. Now let's quickly consider our OPVER, O-P-V-E-R. We had an even root, because it's a square root, and now we have an odd-powered variable. So what does this mean? We're going to use our absolute value bars. We'll put them in green. And here's the odd variable. So here's your final answer. If you leave off the absolute value bars in the problems, you won't be penalized. Now we notice we're working with a cube root. 8 and 9 do not simplify. So let's separate the radicals. So we separated the radicals and broke them down into primes. Since it's a cube root, we need a group of 3 to come out, and we have 3 2's. Okay, so to come out of the bottom, we need a set of 3's. We only have 2. So what we're going to do is rationalize. We're going to multiply it by the cube root of 3 times A, and we'll do it to the top as a property of equality. So now when we simplify, we'll be able to bring it out because we have 3 of everything. So here we have the 2 that's on the outside, which was here, and we're multiplying it by the cube root of 3a squared. So that's what we have in our numerator. In the denominator, we multiplied the cube root of 3 times 3 times a times the cube root of 3 times a times a. So we put everything under one radical, and look at this. We have 3 3's, so that comes out, and we have 3 a's, so that comes out, which means our final answer is voila. We don't have to consider upper because this is not an even root. We are going to start by seeing if we can simplify the radical, break it down. Here we are. Since we are multiplying, what is outside the radical gets multiplied together, and what's inside the radical gets multiplied together. So here we go. The commutative property allows us to move numbers around like this because order doesn't matter with multiplication. So 2 times 3, and here under the radical, square root, so we can put it all under one radical. 3 times 2 times 5 times 5 times 2. So let's look for pairs. So we found our pairs. We have a set of 2's, so a 2 comes out. We have a set of 5's, so a 5 comes out. And we multiply that by what's already outside the radical. And 3 didn't have a pair, so it has to stay in. Let's simplify and finish it up. Final answer is 60 times the square root of 3. Didn't have to worry about OPVER because guess what? We didn't have any variables. Yay! This concludes the video. Time to take the quiz.